So finding the domain from a formula is actually not too hard. We just need to look out for those two main sort of potential problems. Finding the range from a formula is, I think, actually a little bit more difficult. Now, a couple of strategies. One is just to look for the domain first and then make some assumptions about what y must be based on what x can or can't be. Another basic principle is to just remember that if you've got a division problem, or in other words, a fraction, it can only have a solution of 0 if the numerator was 0. And that's obviously because we can't divide by 0. So if we're doing a division problem and we're getting 0, then the only way we can do it is if we started with 0 and then divided by anything else, really. So I think this will make more sense if we look at some examples. Now here, we've got the potential problem for the x value here. It needs to be at least 4, right? Because if it's anything less than 4, we're going to have a negative in there. So we know that this thing only exists for x values that are greater than 4. But also we know that when we take the square root of a number, we're going to get a positive number. So we can tell here that the smallest that this whole right-hand side of the equation could possibly be is 0. So the range basically is just that y has to be greater than or equal to 0. We can tell that because any square root that we find is going to be positive. It could be 0 though. For the next one, okay, similar, except there's a problem. There's often problems when you're finding ranges. And the further we go in this course, the easier this will get because you'll be able to recognize, oh, that looks like the formula for a semicircle. If you can't now, that's totally fine. Now, if you can draw a graph and say, hey, that's a semicircle that's going like this between 2 and -2, you're miles ahead because then you can just read off the graph what the domain is and what the range is. If you don't recognize that that's a semicircle, well, you might have in the beginning worked out that x had to be between 2 and -2, because if it's any bigger than 2, this whole thing will be negative, and if it's any smaller than -2, then this whole thing will be also negative. Once you've considered that it's between -2 and 2, it makes sort of sense. You could even draw up a table of values and say, well, what's the graph doing between here and here? You know, it can't be doing anything too crazy. It's going to be predictable. And once you've got this basic shape nailed down, and you can see that the y values are only going up to a maximum of 2 there, the range is going to be that y has to sit between 0 and 2. And it could equal them, because after all, if x equals 0, we've got 4 minus nothing, and the square root of 4 is 2. So things to investigate, I suppose, for one like this is look at the extremes of what x can be, and then perhaps look in the middle as well, and because that middle point actually gives us the high point there for the y value. Now, these two have both got fractions in them, so they jump out at you as being a potential problem for the x. We can see in both cases that x can't be 1, and that's quite easy to spot. But what we're talking about here is we're saying, look, if we've got 2 divided by something, what can't y be? Well, y can't be 0 in this case. And it's harder to spot than it is when you're looking at the domain. But the reason is if you're getting 0 over here, it could only be because you had 0 on the top. And we don't have 0 on the top. We've got 2. So 2 divided by anything at all in the world can never equal 0. Now, that's a harder one to spot, but with practice, you're going to get used to these. We need to say that y can be anything, really. So we'll write all real y, except y cannot equal 0. Now, this last one is tricky. If you followed that same method from the one before, you'd probably go, oh, hang on, y can be 0 here because x could be 0. X just can't be 1. And if x is 0, we could have 0 divided by something, and we could get 0. Okay, there's a problem here. X can be 0, y can be 0, x can't be 1. We're trying to look for what y can't be. I've given you 2 strategies here, and neither of them are going to work for this one. Okay, so it's tricky when you're finding range. Sometimes there's exceptions. Now, I would just look at this one and go, what are the potential problems here? Well, we've got something divided by something else. And looking at x and x minus 1, I can tell that no matter what x is, x minus 1 is going to be a different number, isn't it? So if x is 5, x minus 1 would be 4. If x is 6, x minus 1 would be 5. These two are never going to be the same number, are they? One is always going to be one smaller. Range, all real y, except y cannot equal 1. Now, the reason it can't equal 1 is because when we divide something by itself, you get 1. And this is never going to be something divided by itself because these two numbers here, no matter what we sub in for x, are always going to be different. So I guess I'd add a third thing in here, try to spot other problems. And that's just, you'll get familiar with looking at different equations and looking for what values of y can or can't exist.